Recording. Hi everyone, good morning. Today is March 8th, International Women's Day. Okay, and today we will continue with session. We haven't finished 3.1, so we'll finish 3.1 and start 3.2. We are a little bit behind schedule, but it's okay. We can catch up later. This Friday, you have homework 6 about 2.4, 2.5, and 2.6. And your quiz 3 will be from 2.2 to 2.6. Mainly focus on 2.5 transformations. I told you last time, our course website, there is a 2.5 practice problem and the answer. Did you do that? Not yet? Please do it. I want you to do well on the quiz. So please do it. Yes. The group. Oh. Yeah. Yes. Right. Okay. All right. So, and don't forget that I want to meet you weekly. So, review your notes and then do this 2.5 practice problem and then check the answers. If you have questions, ask me. Okay, everybody?
Where can we find this?
On the course website. So, and then you go to week 7, the 2.5 practice problem and the answer. Remember the translation? What's the first one? Left and right. Second one. Reflection over the y-axis. The third one. Yes, and vertical stretch. And then the last one. Up and down. Use your hand. Okay, let's do math exercise. Left, right, and then what? Reflection, and then reflection, stretch, up, down. Right? Yes. Okay. So your muscle can remember it, right? Yes. Okay, let's continue. So last time we talked about 3.1, right? Quadratic function. And then we have the general form ax squared plus bx plus c. A is the coefficient of x squared. It's also called the leading coefficient. Leading term is the highest power term. Terms are separated by plus or minus. Okay? So A is the coefficient of the leading term, so it's the leading coefficient. B is the coefficient of x, and C is the constant term. That is the general form. And then the standard form or the vertex form is A times x minus h squared plus k. Okay, keep that in mind. This is so important. Oh, we have handout today. Yeah. Okay, and then if we're given general form, how to change it in terms of the standard form or vertex form. This is the formula. Last time I showed you why we get this formula, right? So keep that in mind. H equals b over negative 2a. And k equals f of h. Okay, everybody? All right. And last time we did example 3. Right? We figure out A is 2, B is 8, C is 7. And then we plug in the formula. H is B over negative 2A. So we plug in, we get negative 2. And then K is f of H. So H is negative 2. That means whenever you see X, replace X with negative 2. Right, everybody? Mm-hmm. And therefore we get negative 1. So, and then this is the standard form. So we plug in A is 2, H is negative 2, K is negative 1. Therefore, this is the standard form of the parabola. And the axis of symmetry is x equals h. H is -2. So axis, do you see is a vertical line? So vertical line is an equation. It's not a number. Okay, so x equals -2. The vertex is the point because here our A is positive, so our parabola opens up. Do you remember that if A is positive, our parabola opens up? If A is negative, the parabola opens down. So the vertex is where the parabola intersects the axis of symmetry. And in this case, it's the lowest point of the parabola. Okay, everybody? So we also know, okay, then this is the minimum, right? From the picture, we know this is the minimum. Let's continue. Example 4. Sketch the graph of the following. Identify vertex, the axis, and the x-intercepts. So last example, we didn't do the x-intercept, but example 4, it asks us to find the x-intercepts. Okay. So what is A? -1. What is B? 6. What is C? -8. So A, B, C. Hi, Dylan. We have a handout today. A, B, C are constants. So don't include the x in it, okay? So sometimes some mistake could be like B is 6x, A is -x². No, don't include the x, okay? A, B, C, they are constants. No x in it. Okay, and then H is, so the formula is B over -2a. Right, everyone? B over -2a. And then B is what? 6. -2a was A? -1. Ooh. What is that? Yeah, -2 times -1 is 2, right? 6 over 2 is 3. Oh, that is H. And then K is f of H, but H is 3. Okay, so we plug into the function. We get, whenever we see x, we place x by 3, right, everybody? So we have negative x, replace x by 3. -3 squared plus 6 times the positive -8. What is -3 squared? -9, right, everybody? Because we don't have parentheses, then it's still negative. Yes, everyone? 3 times 6 is 18. What is -9 plus 18? 9. 9 minus 8? 1. Yes. K is 1. Attendance. Ooh, it's the 8th week. Can you imagine? It's already the 8th week, half of the semester. Okay. All right. Now, what is the standard form? Standard form, right here. Yes, everybody? So we plug in. What is A? -1. And then keep going. The A is -1. X minus H. What is H? 3 squared. Plus K. What's K? 1. Yes. So this is the standard form of the parabola. Vertex. So read the problem carefully, right? Vertex. Vertex is H comma K. H is 3k is 1. S is what? What's S is? 3? Remember, S is a line. Line, you give equation. What is the equation? Vertical line. So you put what? X equals 3. Okay, everybody? X equals 3 is a line equation, not a number. Okay, and so now we can sketch because 3, 1. So 1, 2, 3, and 1. This is the vertex. Tell me the parabola opens up or open down? Down. Okay, so like that. But the problem also asks us to find x-intercept. Okay, so x-intercept. Well, x-intercept, do we set x equal to 0 or y equal to 0? Y equal to 0. Right, everybody? X-intercept is where the graph plus the x-axis. Yes, everyone? Plus the x-axis. X-axis, y equal to 0. Y-axis, x equal to 0. Right, everybody? So we set y equal to 0. That means negative x squared plus 6x minus 8 equals 0. Right? And let's solve it. I don't like the coefficient of x squared being negative. So let's multiply by negative 1 on both sides. Yes, everybody? So we have x squared, then what? Plus or minus? Yeah, minus 6x, and then plus 8 equal to 0. How do you factor it? Negative 2 and negative 4, right? Yes, everybody? Negative 2 and negative 4. Yes, take notes, take notes. Negative 2 and negative 4. So we set x minus 2 is 0 or x minus 4 is 0. What's x? Back to x is 2 or x is 4. So x-intercept or y-intercept, they are points. X equals to 2, this is an equation, this is a vertical line, okay? So when you answer x-intercept or y-intercept, they are points. So they are 2, 0, and 4, 0. Therefore, in the picture, we now know that the x-intercept is 2, 0. So this is 2, and this is 4. So this is where the parabola plus the x-axis. 2, 0, and 4, 0. Okay, everybody? And look at the picture. Do we have maximal or minimum? Maximum. And so this is the maximum. Do we have minimum? No, no minimum. Right. Okay, so that finished the whole problem. Okay, you in exam 2, you have a problem like this. You are given the general form, and then you need to find the vertex form. Okay, use the formula for H and for K. Then you write down the vertex form, and then figure out the vertex, figure out the axis, and then it depends on your A. If it's positive, then open up. If A is negative, then open down, and then you can sketch the parabola. And if the problem asks you to find the x-intercept, you set the y equal to 0 and solve for x. And you get points. X-intercepts are points. They're not equation, not vertical line, not number. It's a point. Point is the order pair. So parentheses, x-coordinate, comma, y-coordinate, parentheses. Right, everybody? Mm-hmm. Okay, any questions about example 4? All good? Okay. Example 5. Write the standard form of the equations of the parabola whose vertex is 1, 2, and that passes through the point 3, -6. Okay. 1, 2. 1, 2. So this is the vertex, right? It passed through 3, -6. So it is kind of like that. Can you imagine, everybody? We have the vertex 1, 2, and it passes through the point 3, -6. Okay? So we can draw the graph, and it gives us an idea about it. Right? Now, what do we do? Write down the vertex form. Okay? Y equals A times x minus h squared plus k. All right. In this case, we already know the vertex is 1 and 2. 1 is h, 2 is k. Is that okay, everybody? The vertex is h and k, right? So h is 1. Let's plug in. H is 1. What is k? 2. Right, everybody? Okay. So there are 3 parameters here, A and H and K. We need to figure out that. We already figured out K and H. But we still need to figure out A. That's why the problem gives us the information. The parabola passes through the point 3, -6. Okay? So we plug in 3, -6. So we plug in x is 3, y is -6. Yes. So we we plug in 3, -6. So y is -6. X is what? 3. Right? We plug in y is -6, and we plug in x is 3. Okay. What is 3 minus 1? 2. 2 squares. 4. So -6 equals a times 4 plus 2. What do you do? Okay, Diana, what do you do? We want to find the a, so how do we find the a? Yes. Subtract the 2. And what is -6 minus 2? -8. Haley, what do we do next? Divided by 4. And what is -8 divided by 4? Yes. Good. Now we plot this back here. We get y equals -2 times x minus 1 squared plus 2. So this is the standard form of the parabola. Okay. So in exam 2, you also have a problem like this. Okay. So as long as you memorize the standard form, you plug in number and find the parameters A, H, and K, and then plug it back. Okay, everybody? Awesome. Okay, so, and then, yeah, vertex is the maximum or minimum. Depends on the picture. Look at this picture. The vertex is a max or min? Max, right? And look at this picture. Your vertex is max or min? Min. Okay, yeah, so that's it. Because we are behind schedule, I will let you to do at home for example 6. Okay? So now let's look at 3.2. Everybody get a new handout? 3.2? Yes? Okay. Any questions before we start 3.2? Good. All right. So don't forget that when you review your notes, when you do your homework or do the quiz, or if you haven't submitted your practice exam, you can still submit that and you get 10 points. Okay? And also, if you haven't submitted your exam correction and record, please do those. There's also 5 points for exam correction and 5 points for the exam record. Okay? So they are practice exam and exam correction and record. They are part of self-assessment. It's 5% of your total grade. And you can get perfect score on that 5% if you work hard and do the work. Okay, everybody? And sometimes you realize, even though you don't get the full 10 points because you missed something, I let you resubmit and gain those points back. Right, everybody? So you have a lot of chance. I hope the homework you do it, you get 5%, right? And then self-assessment, you do it, you get 5%. Those 10%, I hope everybody can get perfect 10%. It can help you to raise your ability. Okay? And I know many of you didn't do well on exam 1. Study hard from now on. You can use your final exam score to replace the lowest midterm exam score. And I hope exam 1 is your lowest. Yes? Mm-hmm. So you can still get an A. Let's try our best. Okay, polynomial function. So we learned about linear functions, we learned about quadratic functions. Now let's increase the degree. Okay? A polynomial function of degree n is a function that can be written in the form of an x to the n plus a sub m minus 1. So this notation, these a1, a0, they're just constants. Okay? So they are just constant coefficients. Okay. Polynomial functions are continuous and smooth. This means no gaps, no holes, no cups, no corners. Okay, so this is a polynomial. It's very smooth. Okay, no gaps. Like here, no gaps, no holes, no cups, no corners. Okay, so this is not a polynomial. On the left-hand side, this picture is a polynomial. It's very smooth. Okay, and continuous. And then the end behavior. The end behavior of a function means how the function behaves when x goes to infinity or x goes to minus infinity. Okay. Look at the x-axis. The right-hand side is more positive. The left-hand side is more negative. Right, everybody? So when x goes to infinity, that is to the left side. And then x goes to minus infinity, that is to the left side. Did I say left side? Right side. Right side. This is my left, and then this is the right. Okay. So look at this picture. Here, do you see when x goes to infinity, the y goes down? Down means negative infinity. Okay, so x goes to the right, the y goes down. That means y goes to minus infinity. Okay, how about on the left? You see? Left, x goes to minus infinity. The y is what? Up or down? Up. So y goes to positive infinity. Exactly. Yes. So for non-constant polynomial functions, the end behavior is either up or down. Okay, y goes to infinity or minus infinity. So up or down. Okay. The highest degree term of a polynomial is called the leading term. Okay. And the leading term determines the end behavior of the polynomial. And in this case, the a sub n, is called the leading coefficient. So far, so good. So some terminology. And it's the highest power. That's the degree of the polynomial. And the highest power term is called the leading term. The coefficient is called the leading coefficient. Okay, everybody? All right. Now, determine the end behavior of the following polynomial. Okay. All right. So let's draw some picture. Okay. What's the graph of x squared? Look ahead. X squared. X cubed. Like that, right? Actually, for all the even power, so let's say x to the n, when n is even, they all look like a U shape. Okay? So n is even. They all look like a U shape. And it pass through 0, 0, and 1, 1, and minus 1, 1. Okay? They all pass through these 3 points. Now, you can see when x goes to infinity, what do you say the y? Up or down? Up. So y goes to infinity. How about when x goes to minus infinity? Goes to infinity as well. Yes, everybody? Mm-hmm. Okay. Now, how about x cubed? Like that, right? So all the odd power looks like x cubed. Okay? Just the shape is a little bit different. So it passed through 0, 0, 1, 1, and minus 1, minus 1. Okay, now tell me when x goes to infinity, what happened to your y? Goes to infinity. And when x goes to minus infinity, what happened to your y? Negative infinity. Exactly. So this is what happens in general. Depends on whether it's even degree or odd degree. Is that clear, everybody? Mm-hmm. Now, come back to our example. Okay. So keep that in mind. The leading term determines the end behavior. So if the problem just asks you to find the end behavior, we only look at the leading term. Don't look at the smaller term. Okay, everybody? Only look at the leading term. Okay, let's start with that. Do you see it's x to the fourth? X to the fourth look like this, or that one, right? It's even power. So you start with x to the fourth. It look like this. And then remember when you multiply by negative 2, what are you doing? What is the negative due to it? A reflection over the x-axis, right, everybody? You remember if negative is in front of the x, then is refraction over the y-axis. If the negative side is in front of the whole thing, then it's refraction over the x-axis. What happens with the 2? Is the 2. You multiply by the 2. Stretch. Right, everybody? Yes. So, okay, maybe let's think of it two way. Okay, two step. This is reflect over the x-axis. Okay, so like that. And then this one is what? Stretch. Stretch by a factor of 2. So it's more like skinny, right, everybody? Okay, now look at the end behavior. When x goes to infinity, what do you say? Y goes to negative infinity. When x goes to minus infinity, what do you say? Yeah, y also goes to minus infinity. Okay, so that is our end behavior. So far, so good, everyone? Okay, now you do example 2.
So we don't have to do anything for 5x cubed or 4x.
Right, it's smaller, just equal.
Oh, so you do, okay.
Yeah, exactly. That's why the dominant with the leading term determines the end behavior. We don't care about the smaller term. It's like, because x goes to infinity. It's like, if you have $1 million, do you care about a penny? Maybe not that much if you only have 50 cents, right? Yes. Yes, it looks like that. So you go extra.
So it's passive,
Oh, that is the shift left or right. You stretching because they're not x plus or minus or multiplied, right?
So
Okay. Okay, let's draw it together. Okay, so, alright. Maybe the last example is better to put some key points. The key points are 0, 0, 1, 1, and minus 1, 1, right? And when you flip it over, you get 0, 0, and then you get 1 minus 1, and you get negative 1, negative 1. And what do you do when you multiply by 2? It will be the y coordinate multiplied by 2. Remember your x coordinate remain the same, but the y coordinate we multiply by 2. So you in fact get 1, negative 2, and negative 1, negative 2. So right now, our leading term is 3x to the 5th. X to the 5th looks like x cubed. So the key points are 0, 0, 1, 1, and negative 1, negative 1. Right, everybody? So this is x to the 5th, look like that. And then when you multiply by 3, what do? Your x-coordinate remain the same, but the y-coordinate changes to 3, right? And how about -1? -3. Okay, you connect them together. Do you see when x goes to infinity, what happened to your y? Up or down? Infinity. When x goes to minus infinity, what happened to your y? Negative infinity. Yes.
So it's skinnier.
Skinny, stretching. Stretched by a factor of 3. Yeah.
So be straight.
Right. Okay, everybody? All right. So this is example 2. Okay. Now, the remaining, you can do it as an exercise. Okay. Oh, by the way, any questions about example 2? Yes. This one? We look at the highest power. Which term is the highest power? 3 to 4. So look at this one and ignore the rest. Yes. And here, what's the highest term? 5x to the 7, right? So this is the leading term, ignore the rest. So the order, it might be not from the highest power to the lowest power. We just focus on the highest power. Okay, yeah, good. Okay, keep going. Notes? A 0 or root of a polynomial is a value of x such that f of x equal to 0. The 0 corresponds to factor, and graphically they correspond to the x-intercept. For example, if I draw a picture and then something like that, let's say this is f, okay? And let's say this polynomial or roots of a polynomial. Be careful, 0 is not necessarily 0. Okay? be careful, 0 of f might not be 0.
When it's saying zero, is it like 0 on the y-axis?
Yes. 0 of the y coordinate is on the x-axis. X-axis, the y coordinate is 0.
What would you say for 0 on the x-axis?
Yes, kind of. Like the x-intercept.
What would you do if it was like on the y-axis?
Then you call y intercept. You don't call 0 or root. 0 or root is only for the x-intercept. Okay. Example 3. If f of x equals x squared minus 5x plus 6, then because f of 2 equals to 0, it must have the factor of x minus 2. And there will be an x-intercept at x equals to 2. How do you factor it? X. Yes. So therefore, what are the x-intercepts? You set x minus 2 equal to 0 or x minus 3 equal to 0. And then you add 2 on both sides, you get x equals to 2 or x equals to 3. Right, everybody? So 2 is a 0 and 3 is a 0. That means when you put 2 into the function f of 2 equals to 0. The y coordinate is 0. Right, everybody? It also corresponds that your f of x has a factor of x minus 2. Because x minus 2 is 0. Okay, f of x has a factor of x minus 2. And how about 3? 3 is a 0. Then f must have a factor of x minus 3. Do you see the sign change? Because you're moving it from the right-hand side to the left-hand side, you have changed the sign. So in general, if you have a 0, C, so in general, if C is a 0, okay, that means f of C equal to 0. Then f has a factor x minus c. Okay? If you have a number, how about, okay, let me ask you. If 5 is a 0, then f must have a factor as well. X minus 5. How about 10? 10 is a 0. X minus 10. Okay? How about 300 is a 0. X minus 300. Exactly. Yes. Okay. Now, graphing polynomial function. So first step, we factor the polynomial completely to find the 0, and then we can plot the x-intercept. Also, plot the y-intercept. So, y-intercept is you plug in f of 0. Okay? And when you find the 0, you're solving f of x equal to 0, and you find the x. The difference, x-intercept, you set the y equal to 0 and you solve for x. Y-intercept, you set the x equal to 0 and solve for y. Right, everybody? They kind of switch. That is the first step. Step 2, plot some text points between the x-intercepts. Okay? And 3, determine the end behavior. 4, graph it. Okay, so now I'm going to teach you 2 ways of graphing the polynomial. Okay? And you compare which way is better. Okay? So let's use 2 ways to do that. Method 1. Okay. Test point method. Okay. So we follow the steps. First of all, we factor it. Do you see a common factor? X, right, everybody? And do you also see the leading coefficient is negative? So let's also factor out the negative. Okay, everybody? So we factor out minus x. What's left? It came out. X squared. Yeah, very good. Thank you. And now we can keep going. Let's see. Zach, do you know how to factor it? So xx. What are the factors of negative 3? 1 and 3. But one of them is negative, right? Yeah. Which one is negative so that you get minus 2? Negative 1 or negative 3? Negative 3. So we have x minus 3 and x minus 1. Right, everybody? So we factor completely. And now we set it equal to 0. Right? To find the 0, we set it equal to 0. And find the x. Oh, sorry. You mean positive 1. Right. Okay, yes. Set each factor equal to 0. So x is 0. X minus 3 is 0. or x plus 1 is 0? Jack, x minus 3 is 0. What is x? 3. How about the next one? Yeah. Okay, now what are the x-intercepts? They are points. Okay, so 0, 0, 3, 0, negative 1, 0. Okay, put it on the graph. 0, 0 here, 3, 0, and negative 1, 0. Right, everybody? Okay. How about the y-intercepts? You plug in x is 0. Oh, but what happened? When you plug in x is 0, you get 0 cubed is 0. 0 squared, 0, and 0. So you add them up, you get 0. Oh, that is why the 0, 0 is the x-intercept. It is also the y-intercept. Okay, everybody? So 0, 0 is both x-intercepts and y-intercepts. Now, test points. Okay, so test points. Do you see this is the x-axis? And then these 3 points separate the x-axis into 1, 2, 3, 4 pieces. Right, everybody? So on each piece, let's pick some test points to plug in F to see whether it's positive or negative. Okay, everybody? Give me a number in the piece. 4, yes. Okay. Let's pick 4. Let's plug in f of 4. What do you get? Negative 4 cubed. What's 4 cubed? 4 times 4 is 16. 16 times 4, 64. Plus 2 times 4 squared. 16. Plus 3 times 4. 12. Right, everybody? Okay, so you can choose to plug in here, but you see it's, the number is so big. The other way is you can choose to plug in the factor form. My recommendation is plug in the factor form. Okay, so plug in the factored form. Now, what do you get? Negative 4, right? X is 4. Times 4 minus 3 is 1, right? And 4 plus 1 is 5, right? Is it positive or negative? Negative 4 times 1 times 5. Negative. So, therefore, negative. The graph, oops, I don't want to erase it. The graph looks like below. Okay? If it's negative, then it's below. Then do you see, in the factor form, you can tell right away. You don't need to use your calculator at all. Do you see that, everybody? So plug in the factor form. Don't plug in the original form. Can you give me a test point between 0 and 3? Pick a point. 2. So pick a point 2. All right. F of 2 is plug in the factor form. Negative 2 plus 2 minus 3. 2 minus 3 is negative 1. 2 plus 1, 3. Positive or negative? Negative? Minus 2 times minus 1 times 3. Positive. Positive. So which means on this piece is above the x-axis. Okay. -1 and 0. We pay -0.5, right? What is f of -0.5? -0.5 become positive 0.5. 0.5 minus 3. Negative 2.5, right? 0.5 plus 1. 1.5. Positive or negative? Negative. So above or below the x-axis? Below. Okay, finally, pick a number here. -2. So f of -2. -2 is positive 2. -2 minus 3. -5. -2 plus 1. -1. Positive or negative? Positive. Above or below the x-axis? Above. Yes. So low side. Okay. Yeah, let's continue next class. Next time we will learn a different method. And the second method will be much easier than plotting points.
Yeah, I did this in high school, and I feel
Yes, we will talk about that. I will talk about both methods, and then we will see
like
what
this
the
is
second
so
one.
much easier to do this.
Yes,
I hope
exactly.
that covers it.
Okay.
Took me a second to realize what we're doing, though.
All right.